This is Lab 2 audio part. In this lab, we're asked to create a basic delay filter. So here we're given an example code and we're asked to reduce the delay time during the signal. Okay, so if we have a look at the original example code, you can see that the delay time and filtered audio data, it's all being written in the setup, which means it will only be called once. This function will only be called once at the very start of this program. And if I want to reduce it, it means I have to change the number of delay time every time. It cannot only be called only once. So what I did to my code is I changed delay time into a global variable instead of a local variable to setup function. And at audio, I initialized it to 4410 in the setup function. And I moved the for loop for filtered audio data into general audio out function. And after each time for loops finished running, I will reduce delay time by 100. And setting the condition here, because 4410 is not a multiple of 100. So that means if I set it to delay time is larger or equals 0, there will be a time that delay time will be smaller than 0. In this case, it will get to -90, which will make the array go out of bound here. So that's why it's been set to 100. So if I try some other time, like delay time take away 200, then this will be 200, unless this number is that 4410 can be divided by it, and this can be 0. Otherwise, it should be the same as the number that you're subtracting away from delay time. So let's listen to this. Okay, so you can't hear the delay anymore. And that's the first part to the lab. The second part, we were asked to change the feedback level and assign it to mouse Y. So this line, as you can see, is where the delay line, where the audio data will be put into delay line. And this is the place where I decided to add the mouse Y and height to control the feedback level, because the feedback level should be between 0 and 1. So I use mouse Y divided by height, which would definitely be between 0 and 1, and multiply it by audio data. So this will act as a feedback data. Okay, so that's the feedback level control done, and this part, I can see that, well, this is from the example code already, but as I can see that mouse X divided by width, so if I move it to the left, the delay time will be reduced. And if I move the cursor to the right, then the delay time will be larger. So here, if I move the sketch, if I have the sketch, I move the cursor in the sketch, then on the left side, I can't really hear the delay. On the right, and going down to the bottom, I can hear the delay louder and clearer. So, okay, you can't really hear anything. Still can't really hear the delay, but if I move it back towards the bottom, you can hear it very clearly. Okay, so that's it to lab 2, the audio part.